With each WAN solution, there is an encapsulation type. Encapsulation that is often used as an alternative to leased lines when leased lines prove to be cost prohibitive. With frame relay, you can have a single serial interface on a router connecting into multiple remote sites through virtual circuits. You should be familiar with many terms when working with frame relay. Your virtual circuits can be either permanent or switched. A permanent virtual circuit, PVC, is always connected and once up operates very much like a leased line. A switched virtual circuit, SVC, is established only when it is needed. Of these two, PVCs are much more common. Circuits are identified by data link connection identifiers, DLCI. DLCIs are assigned by your provider and are used between your router and the frame relay provider. In other words, DLCIs are locally significant. For example, assume you have 3 routers named Sleepy, Grumpy, and Bashful. The Sleepy router is connected to the frame relay provider that provides permanent virtual circuits to both Bashful and Grumpy routers. DLCI 100 defines the PVC to Bashful, and DLCI 200 defines the PVC to Grumpy. Although it is not shown, Bashful and Grumpy will likewise have DLCIs to define their PVCs back to Sleepy. As an analogy, DLCIs are like shipping docks. If you work for a shipping company, you might have several ships attached to docks that are each going to a different destination. When you have a package to ship, you just need to take it to the ship headed for the destination. It is the captain's job to know how to reach the destination. DLCIs are like these docks. They are significant only on your side. You send your packet out to the relevant DLCI, and the provider's job is to figure out how to get that frame to its destination. Behind the scenes is a little helper called Local Management Interface, LMI, that works as a status inquiry and reporting message. LMI messages are sent between your router and the frame relay provider's equipment to verify and report on the status of your PVC. The 3 possible states that your PVC can be in are active, inactive, and deleted. Active is good. Active means that everything is up and operational. Inactive is bad. Inactive means that you are connected to your frame relay provider, but there is a problem with the far-end connection. The problem is most likely between the far-end router and its connection to the frame relay provider. You should contact your provider to troubleshoot the issue. Deleted is also bad. Deleted means that there is a problem between your router and the frame relay provider's equipment. You should contact your provider to troubleshoot this issue. Because of the frequency of LMI messages sent between your router and the frame relay provider, LMI is also used as a keep-alive mechanism. Should your router stop hearing LMI messages, it will know that there is a problem with your PVC. There are 3 types of LMI. These can be manually configured or, with iOS 11.2 and higher, can be auto-detected. The 3 types of LMI are Cisco, ANSI, and Q933A. The Committed Information Rate, CIR, is the guaranteed rate at which you are allowed to pass data for a particular PVC. When ordering a PVC, you will request a local access rate, the bandwidth of the physical connection, and the CIR for a PVC. For example, you may order a T1, which has a local access rate of 1.544 megabits for the Sleepy router, and a CIR of 128K for the PVC to Bashful, and a CIR of 512K for Grumpy. Frame relay is a non-broadcast multi-access medium, which means that broadcast traffic is not allowed to traverse frame relay traffic. There are ways, however, to circumvent the NBMA nature of frame relay to allow broadcast to cross the frame relay cloud.